A over m, square root of that. So if you multiply by m, divide by m, it becomes m squared over m. Then the m squared, you pull it outside, it comes as m. Then you are left with k over m. Root of km over m is that. So it changes to that. And this is the critical damping coefficient, Cc. Are we together? Then besides that, C over Cc, because Cc now the critical damping factor is a comparison point. You look at the actual damping in a system, you compare it to the critical, then you say what nature of damping there is. So, C over Cc, we define it as damping ratio. It compares the actual damping in a system to the critical point for that system. And we call that the damping ratio. Are we together?
Yes.
Right. Now, so we've now introduced Cc, we've introduced zeta. Omega n, we still know omega n. Then the next thing to introduce is, so far we are aware of this one, undamped natural frequency. In the presence of damping, this term here is the speed, in the same way that that was the speed when there was no damping. You are going to see when we characterize the expression of the actual motion. When we're saying cos omega t, it becomes cos of the whole thing t. Are we together? So this is the actual frequency when there is damping. And we call that the damped natural frequency. In other words, omega d is equal to this 1 over 2m root of c squared minus 4 km, or equal to c over 2m squared minus k over m. That's omega d. Are we together? That's the damped natural frequency. Now let's look at what happens when damping occurs. Okay, before we do that, we want to rewrite this expression in another way. We can write it that way. We can write it that way. Let's write it in another way. Right. In this expression, 2m omega n, they are friends, ne? Can you see that? 2m omega n. So, I can put a Cc there, which means I've divided by another omega n. So to make sure it doesn't change, I must also multiply by omega n, which means this becomes C over 2m. C omega n, 2m omega n. Did I change anything?
No.
Right? Which is equal to C omega n. 2m omega n is Cc. Cc. Did I change anything? Okay. C over Cc is your zeta, ne? Damping ratio. So that whole term, we can write it that way. Which means we are going to say minus zeta omega n. Let's look inside the brackets. C over 2m, that's what we have there already. And it's that. So in the bracket, plus or minus, in the bracket, there is still the same thing. Zeta omega n, all that squared. Are we together? Then we have k over m. K over m omega n. omega n squared, we can pull this out. Because it's coming out of a square root, we root it, and we get omega n. Are we together? We have written it in a nicer way, in a control system kind of way. This is what we meet in our automatic control. If you are not using HANA, HANA does not write this way. So when you go to automatic control, you can see its vibration because this is exactly what they are working with. Are we together?
Yes.
Right. So